We're getting ready here.
Okay.
Okay, it sounds like I'm ready.
Okay, you're ready.
I'm ready. You're ready. There's six of us ready. Doggone.
Well, I
Hello
got
again,
16 seconds
everybody.
left.
This should be number 208 episode of our club's weekly vlog, the SBAU Astro Hour, with Santa Barbara Astronomical Unit on stage and on the screen. I'm your proud host, the VP of the club, Ronnie Heron. Introduce you to the rest of the guys. This program represents the last week of our fourth year on YouTube, starting year number 5 next week. Let's do the math. 52 weeks in a year. This is number 208. We're still headquartered at the Santa Barbara Museum of Natural History, everybody. Very much caught up in the constant evolving, cutting edge cosmology of the 21st century. And I'm going to try not to push my voice too hard here. SBAU.com. Here's what we're talking about this weekend. This Monday morning, actually. What is today? The 2nd through the, not the 2nd, the 24th, second month. NASA updates our chances of being hit or missed by that 180-foot across asteroid 2024 YR4. We could even hit our moon. We have this week's Sky and Telescope Planet Roundup, and there's even a galaxy grouping out there. This morning's New York Times said the other 7 sister planets are lined up just after dusk. There's even, let's see, we're going to do an Astro Hour review of science. Perfect time, changing of years here. Reference to Isaac Newton, Einstein, Carl Sagan. We're going to talk about relativity, laws of motion, tidal forces, and volcanism, Roche limits, even some interesting new objects called planets. What the hell is a planet? What could it possibly orbit? Let's meet the guys. What? What'd you say?
A broken planet.
A broken planet, man. I tell you,
Broken
the
planet.
things I'm learning in this amazing
That's just a
meeting.
guess.
I know. I'll get to you, my friend. That's Bruce. Jerry Wilson is on screen. Pat
Good
Forgy, his
morning.
wife,
Good
beloved
morning.
president. 7 years, 8 years. We get lost in time, don't we, at our age?
Yeah.
Your wife's a great supporter and a supporter of mine, too. I love her. Chuck McPartland is our outreach coordinator in front of the Ukraine flag, which I hope he can keep up there. Pat, he's married to Pat McPartland. Between them, they handle 3 different offices in our club. Bruce Murdoch joined us early. He's married to Bonnie. And Bruce is president of the Santa Barbara Theater Organ Society, but he has more fun with our club as just a member. Tom Whittemore joined us. He's married to Maureen, past instructor at Westmont College. Always smells like raisin bread for some reason every time you see him. Did I say he edits the newsletter? Tim Crawford, resident lens and telescope expert, is wearing. You want to show off your new whatever?
Oh yeah, look at that. The sun.
What's it say on there?
Oh, moon, sun, moon.
For some reason,
Are
it
you gonna moon
obliterates.
us?
Why does it take your picture off the screen? I don't understand that.
Because of the background picture.
I think it does face recognition, and when your face goes off, it takes you off.
Yeah, it considers you now the background.
Is
Yeah.
that right? Well, President Jerry, I only got one silly science cartoon forwarded to us, so you're probably going to hit us with a bunch of
Well, there's
surprises.
two things coming up. One is the tidal forces and Roche limit. That was a title, and I had ambitions to write something about that, but it got too late, and so I forgot to take that title out. We're not going to have a topic on that unless it's a burning issue for you.
Well, it's on the. I just go by your incredible.
I know, that's fine. I just forgot to take that out. And the cartoons on science and technology have changed over the years. There's less of them that are good, and they take a more political stand now is creeping into them. So
Yes,
I try and avoid most of that, but as you'll see, we still get a little bit.
They're trying to survive.
Yeah.
Okay, well, I only got one. Something about the misinfo desk at QAnon or whatever. You want to throw that one up on screen?
Well, I've got, I think, 5 of them here. I didn't send them all.
Okay, then there are going to be surprises for all of us. Open to any commentary you want, guys, because I haven't seen them. Can you enlarge it? Traveling at thousands of miles per hour, objects re-entering. You made it too. I lost the top part of the re-entering the Earth's atmosphere can reach temperatures of up to 7,000 degrees Fahrenheit. Who is this? Somebody under a tree?
It's
Reading
Mother Goose.
Well, it's Mother and Goose, space
Yeah, I like
science
the
for
bottom
beginners.
one. Yeah.
And the cow jumped over the moon. And there is the big crater in Arizona at the bottom, which is that where the cow landed?
Mother Goose's self-serve deep pit barbecue, beef
Oh,
barbecue.
I see. Okay, I now see it now. It's almost washed out on my screen.
So we're trying to get science into fairy tales.
Well, you'd think this man was a grandfather in another city with his grandchild, not getting that to us. Here's another one. He's reading on the outside of a space station. The astronaut reads, really fed up with doing this after every spacewalk. Oh, he's
This
entering
is
that?
CAPTCHA, which means you got to prove you're not a robot.
Oh.
Or in this case, not an alien.
Oh, yeah, that's right. Show that you are not an alien now.
I mean, they don't have fingers and hands?
I don't know. Maybe they don't know what a stop signal looks like.
All right. You're going to have to enlarge that, I'm afraid. Evolution, just a theory. I can read that. And she says, I can actually, dear, evolution itself is an observed scientific fact. The theory of evolution is just the current best explanation for that observed fact. You know, just like the theory of gravity explains the observed fact of gravity, and it's not just some wild guess that gravity exists. And I guess the daughter or the other lady says, and remember, Dad, a scientific theory is a coherent group of tested general propositions commonly regarded as correct that can be used as principles of explanation and prediction for a class of phenomena. It's not just some wild guess or baseless assertion like God did it. Oh, okay, so we're going to hit the anti-people, aren't we, today? Here's the dog looking outside at night, I assume. Is another dog nearby?
Yeah.
Which one is, who's talking? Oh, the one looking says to there, you know, there's no moon tonight. But how about howling at an asteroid just narrowly missing Earth? That's a good one. Yep. Okay. Stick figure time. They're talking. It looks like a guy and two girls. And first girl says, the KM3-net deep water telescope detects the flashes of Cherenkov light from neutrino interactions. To which he replies, how do you know you aren't just seeing bioluminescent fish? She says, well, Cherenkov radiation is only emitted when things exceed the local speed of light, so it can't be produced by undersea.
Wait, I thought we had a pun crowd here.
Well, we did. His name
Well,
is Tom Whittemore. Tom is our pun and punster. I don't know why we don't get a punch.
Radiation is the German term is oh come on, it's break radiation. I forgot what the German is.
Bremsstrahlung.
Bremsstrahlung, right.
Really?
Yeah.
Because
I haven't heard a pun from Whittemore in ages. You'd think he'd publish one a month in our newsletter, wouldn't you?
Do you want the newsletter in German?
I heard the guy that came. I heard that they threw the guy in jail that came up with puns, and they said, "Can you think of one now? We'll let you out." He said, "Oh, pun the door."
Yeah.
All right. Is this the asteroid from hell?
This is the recent one. This is 2024 YR4.
Yeah.
They as you know, they looked at it with the James Webb Space Telescope and they refined a little bit the size of it. But new calculations show a significantly reduced probability of it hitting the Earth. And there was also an article I saw in, I believe it was space.com, that another modeling has predicted or has a non-zero chance that it could also hit the moon. But the probability of it hitting the moon was like 0.3%. And that was made before the new down probability calculation was released by NASA. So
For hitting us.
I don't know if that, I was thinking, and the article said that we would be able to see such a collision with the moon, but not if it's on the backside.
Yeah.
So, but anyway, times are, everybody can breathe a little easier, despite the fact that it seems like news sources like to have an increasing chance to scare everybody.
Is this the one, Jerry, that's supposed to go inside our geosynchronous satellites?
No,
Oh, it's going to be out beyond them.
that was a previous,
That's Apophis, and it actually will, but it won't hit us.
right, but this
Apophis.
is not the one that
Yeah.
was first predicted to go inside the 23,000 mile limit. But this is a scale diagram from the recent NASA calculation. Apparently, it's an attempt to do it to scale, and this is where its most probable miss is. Now, the distance between the Earth and the Moon is 250,000 miles. So this is probably about, I don't know, 100,000 miles.
Yeah,
And that's what year we talk about? 29?
2024.
No, it's
23.
2032 that it's
Yeah.
making the really close approach.
Oh, okay. Oh, so the line is the path that it's going to go, not the path that it's gone.
Right.
This is a prediction of a supercomputer plotting of recent observations. And it was
Okay.
released on February 19.
So YR4, it'll be 32. When is Apophis supposed to slip by us?
2029, I think, or 36.
Okay, that's the one I was thinking of,
Yeah.
29.
Yeah.
I know
If
I
if
heard
you're
that.
in like Southeast Asia, you'll get to see it naked eye, but not for us.
You know, when I was growing up, the only thing I heard about asteroids was that they were out in a belt between Mars and Jupiter. Now that I'm old, they're coming in one after another. This is crazy. Where did did this all just start?
No.
Been coming by us all along and we just didn't know it?
Well, the dinosaurs found out.
Yeah.
Yeah.
And as is commonly said, the reason there are no dinosaurs is because the dinosaurs did not have a space program. Now
Nudge it.
the data increase and the accuracy increase from the 50s when I was a kid and started reading Sky and Telescope and other things has been due to the advances of scientific instrumentation and our ability to measure things. If you got something within 100% of the answer, that was good in astronomical terms back in the 50s. Now you can get things, we see what's called the Hubble tension, where the Hubble constant is being refined and it's revealing new problems with what it means. So our data is getting very good because our instruments are getting very good. But the same things happening now that we can see, they were happening then too. We just couldn't see them.
Well, NASA, when
correct.
they do prediction, also takes into account the pressure of light moving the object. And the program that I wrote, I talked about in one of our December meetings, 4 years ago. I agreed, my results agreed with NASA's to 17 places, 17 figures. And I didn't take into account the pressure of light. So it's
You were doing planets.
Pardon?
You were doing planets.
Well, they do it on all of them. They look at the pressure of light on all that stuff.
Pressure of light?
Yeah. Light reflecting off something transits a little momentum.
Yeah, well, I've heard about the sails in space.
Yeah, that's why they work.
Just hard to imagine something that's all energy and no mass at all has some pressure.
It has a rest mass, so it has momentum.
Yeah.
Right.
Go out,
Rest
lay
mass,
in your backyard on a sunny day. Don't you feel the urge to roll over? You
Yeah.
get all that momentum pushing on you.
True, you're right.
Yeah, right.
So this,
Planetary roundup time. Okay, here we go.
so this is our weekly roundup. Mercury begins emerging into the very low sunset this week into view. So it's bright, minus 1.2, but it's too close to the sun. Venus is very bright. The evening star, minus 4.8. It's the thing that looks like a plane landing at your local airport, but it doesn't move.
Yeah, right.
Yep.
It's actually bright for like 6 or 7 hours after sunset now.
Yeah, it's very dramatic.
And yet it's just a crescent.
It's becoming
No. It's in opposition, I think.
Oh, is it? Oh,
No, it's a nice thin crescent right now.
Right.
Yeah, and it's
Crescent.
getting
Oh, okay,
more of a
well,
crescent.
To the naked eye, it's just a big white dot in the sky.
Right. You can't resolve the crescentness of it without binoculars now.
Yeah.
This is 55 arc seconds in diameter by mid-March, a month from now. And that is the size of Jupiter typically. So, and twice as big as Mars at its best opposition. So it's going to be a very pretty thing to see in optical aid or take a picture. Mars is in Gemini. And
Yeah. Yeah.
yeah.
And it's quite orange too.
Yeah. Oh, yeah. It's very noticeable.
Yeah, it was really
Making
impressive.
a really nice triangle.
Yeah.
Oh, you mentioned that. Okay, yeah.
No, I was
Yeah.
just going to say, I was going to say, Chuck, it was really impressive that Andy Allen on Friday at Westmont, even though Mars is only like 12 arc seconds or so, I think I saw Syrtis Major
Yeah,
with
there
telescope. It was really something.
there were smudges of detail. That's a really good scope.
Yeah, yeah. That was really impressive.
Which scope was that? At the
It's an 8-inch.
museum?
Andy Allen's 8-inch.
Oh,
It's a Cintascope. It's a just a commercially available
Yeah.
scope, but he got a very good mirror.
okay.
Mhm.
Does Andy teach at the City College?
No, Andy works for I think Yardi Systems.
Okay.
Yeah.
Okay,
So
that's right.
He used to be at the Goleta Library
Yeah.
when I
That's
first
right.
met him in
He's
our
got a
club.
PhD in something like, some facet of biology.
I see. Okay.
Really
Yeah, that was pretty impressive Friday
gave us
night.
gave us 1 year as secretary.
Yeah, he did an excellent job.
Yeah, but when I first started doing the newsletter, he was our secretary.
Yeah,
and
he's been
the
secretary
swap,
before.
Yeah.
yeah, we used to swap roles of doing setting up the printing,
Yeah.
stuff like that. Yeah.
Oh, it should be on the screen with us.
Okay, Jupiter. This shines all night long, pretty much.
Mm-hmm.
Well, it sets around 1 or 2 a.m., so it's getting more toward the west. We're past its opposition. Saturn is lost deep in the sunset.
Mm-hmm.
Uranus is in Taurus, Aries border, and it takes it takes aid to see it. You're not going to see it with your naked eye. And Neptune is lost in the sunset.
We've got Aries now kind of setting in the west and Leo coming up in the east, and that's
Yes.
March coming in like a lion and going out like a lamb.
Yeah, that's
Yeah.
good.
I
Yeah.
think that referred to the weather mostly, but yeah.
Yeah, and Chuck, one of the most impressive things for me at that last Friday was Chuck's, not you, but Chuck's little, I don't know, sea star or something.
Yeah, Sea Star 50.
Yeah, and I said, "Hey, Chuck, do you know 2903?" He says, "No, what's that?" I said, "Oh, it's a really cool galaxy off of the nose of Leo." And he got it, and he started building the image, and it was pretty impressive.
It was fantastic. Yeah.
Yeah.
But after you left, Tom, it kept building. It was phenomenal.
Yeah, yeah.
Tessa had the horse head in a view that I've never seen.
Yes, yes.
Yeah. Yeah, those sea stars are impressive.
Yeah.
Yes,
Earlier
they are.
on,
They
Chuck
do
had
good work.
Chuck had B33, the horse head in his scope. It was pretty neat building that image.
Yeah.
The objective lens on those is what, like 1.5 inches in diameter, something like that?
50 millimeters.
Well, that's
It's
almost 2 inches.
Yep.
Yeah.
And then they have one that's 30 millimeters with a wider field of view to get the entire Andromeda galaxy.
That was the aperture of my first telescope as a kid, 30 millimeters.
This is really faded out, Jerry.
Oh,
Yeah.
okay.
I can read Pegasus there.
Yeah, I saw Venus.
We got a UC Riverside professor coming in August to talk all about Venus.
Okay.
Going to be
There it
interesting.
is.
Yeah, now you can see this stuff down there.
Yeah. So I think this is Friday,
Yep, that's right.
28, 30 minutes after sunset. And the Friday this would be the crescent moon, not the crescent Venus.
Yeah.
But Venus would look about like this too. It's a very thin crescent, very striking.
Mhm.
Saturn is way down here. They show it in the glow, but it's really lost in the sunset. And, I pointed to said Venus, but this is Mercury. Venus
Yeah.
is up here.
And for people who are up early in the morning, the moon is really pretty right now.
Yeah.
And on Saturday morning, it was kind of like right in the middle of the teapot in Sagittarius. And then today it was closer to Capricornus. Yeah.
I checked out T Corona Borealis this morning, and
Uh-oh. What do you
it
think?
hasn't blown yet.
Hasn't blown,
Okay.
okay.
I almost
I-
went out the other night, Chuck, with just binoculars. Yeah,
I expect to see emergency emails when it does,
Yeah.
sure.
yeah.
How long will that flare last? Do you guys know?
I think it's a couple of like 2 days.
Yeah,
Well, that's neat.
it's-
That's neat.
It won't last weeks.
Yeah.
Okay.
Whatever it blows off doesn't just keep going.
Yeah, it does, but it doesn't keep glowing.
Oh, that's good.
Okay, this is, let me take my glasses off.
Mm-hmm.
This shows the planetarium software view of what we just saw, because Chuck is frequently critical of that kind of diagram.
No, so Sky and Telescope does a good job. It's astronomy that really messes them up.
Oh, okay, okay. I'll hone my knowledge. So this is a similar sky. But this is tonight, or tomorrow night, 25th at 6 p.m. The sky will not be this dark quite a bit. We're seeing the last of Cygnus in the west as they set. Saturn, Mercury, Neptune, and Venus up here. And the great square of Pegasus,
Mm-hmm.
which is easy to spot.
Mm-hmm.
This is a single frame from a computer-generated year on Mars, which I'll show you the video in a second. It's basically doing the same thing for Mars that our weather services do for Earth. They model Earth's atmosphere. Here, this is modeling Mars atmosphere.
Huh.
So let me just take a few moments and
Yeah,
get
and
myself
Jerry,
totally
you
lost here.
could really see Syrtis Major on your display there.
Uh-huh.
And I swear that's the one I saw Friday night in an 8-inch telescope. It was pretty neat.
Mars' south polar cap is bigger than the north.
Yeah.
You'll see.
Yeah, and Chuck, is that a Royce mirror? Is Andy's mirror a Royce?
The
'Cause this-
other one, the one that was 1/32 wave or whatever.
Okay,
Right.
okay. The one we tested at the workshop,
Yeah.
I think. Yeah, okay.
8-inch.
Oh, I think it was 10-inch,
Okay.
but his new one is 8-inch.
8-inch, yeah. Pretty impressive.
Wow. So that's the whole planet, the whole surface area split out.
Yes.
That's why
Yeah, this is all, there's no hidden side here.
got it. Okay.
Oh, okay. All right. I get it now.
So this is and yellow here is dust.
That's a dust storm. Huh.
Yes, that's a dust storm.
When the
Wow.
carbon dioxide in the polar caps turns into gas, it really puffs up the atmosphere and you get enough wind to start kicking up these storms.
Yeah.
Oh,
Yeah, it's got very interesting weather dynamics.
So are we watching seasons change? Is that why
Yes.
the
yeah,
white?
I think you are.
You're watching one Martian year, which is 2 years on Earth.
Oh, really?
And it's got a similar tilt, so you can see the
Yeah.
southern and northern hemispheres kind of swapping winter there.
Yeah, their winter and summer is defined the same way ours is.
But now what is the white that keeps expanding or disappearing? Is it dry ice or is it?
Yeah.
Yeah, it's carbon dioxide.
So carbon dioxide is in their little dinky 1% atmosphere,
Yep.
1% of ours. It's mostly
Yeah,
CO2.
their atmospheric pressure is about 2% of ours, and it's principally carbon dioxide.
Is it really? I'll be damned.
Now down here, you'll see that there's a remnant going on, and that's the water ice.
Hmm.
Okay.
Whoop.
Imagine just like the moon, we're going to want to land on the poles of Mars, aren't we? Get our water.
But
They're
that's
finding
well,
it all over the place in the form of permafrost.
Yeah.
Oh, I see
they
it.
just have to dig for it.
You can see the 3 volcanoes over here.
Mhm.
And the big
Olympus
one,
Mons.
Olympus Mons is the big one off to the left of those three.
Mhm. Mhm.
Oh, off to the left.
Yeah.
Yeah, the big one, Jerry.
Oh, this one, yeah.
Yeah.
Right.
Volcano, yeah. Syrtis Major, I think, is either this or this.
15
it's
high
that
mile. Wow. Okay.
Yeah, it
So
always
if
kind of
it
like
happens
happens.
during opposition, then the dust storm completely, we can see it in the simulation, we can see through the dust, but when the dust storm covers the planet, it just makes it look like a flat blank disk. You can't see anything through it.
Looks like Venus.
The atmosphere is not as, it's not as hellacious as Venus, but yeah.
Wow.
So if science thinks there was water on Mars, do they think it was in the form of oceans?
In the
Yeah.
past, yes.
Yeah.
Would they have been on those darker spots, those mares or plains?
No.
No.
They were all over.
These are mineral compositions that you see.
Ah, okay.
And the red is
When Mars lost its magnetic field, or very much reduced, and the solar wind started to blow into the atmosphere, it blew the atmosphere away.
yeah, broke the water down and the hydrogen left,
Right.
and the oxygen went in it to producing rust.
Yeah, exactly.
Okay. Let's see if I can get out of this.
Wonder what the average temperature on Mars is. Got to be below freezing, wouldn't you
It's
think?
like minus 100. Yeah.
Yeah.
Okay, so when was it ever above 32 degrees to make water flow?
It had an atmosphere.
Is that so? Even though it's that much further out from us, it had enough heat from that,
Yeah.
from the atmosphere, to keep things about a mid-30s, 40s.
Probably higher.
And then it lost its atmosphere. Got blown away.
Is that right?
Yeah, not a good place to have a restaurant, you know.
More night sky here.
Yeah, there's Mars. It's overhead now.
Yeah.
Now this is showing Mars in its place in the sky at night.
Mm-hmm.
This is Orion down here, very easy to spot. Sirius. These are winter constellations that are heading toward the west.
Mm-hmm.
We showed pictures earlier of Uranus over here and Jupiter, and Mars is up here.
And you can see that nice triangle with Castor and Pollux.
Yep.
Yeah.
Pretty. Yep.
I would say that's more of a isosceles. Or it's not equilateral, it's isosceles.
Yeah.
Mars is going back into prograde, right?
I think it's basically stopped right here in transit.
Okay.
Yeah.
Okay. So, wait, I've covered up the key chord. There we go. Now, what's happening here? This is a 2D representation of the 3D range of galaxies around us. The reason I'm showing this is because we are entering February and March is the region of the sky is dominated not by the Milky Way, our galaxy, but we're looking out of the North Pole of the galaxy, Milky Way, and we're seeing these other galaxy groups around. The Virgo cluster up here, which we're part of, and we're right.
And this is late at night during February and March.
Yes.
Yeah.
And this is the second
Tim?
brightest on the Fornax.
Mm-hmm.
Yeah,
What's
Tim.
that?
I was going to say, Tim, that 2903 that you fell in love with.
Yeah.
That's part of the Virgo cluster, actually, even though it's in Leo.
Oh, really?
Yeah, yeah.
Normally, we can't see it this well.
Say that again?
We can't normally see it this well.
What, 2903?
This whole group, suddenly.
That was
every
a diagram. That
spring.
was not. Yeah, go ahead, Chuck.
Every spring, you just got to wait for it to be high in the sky.
Yeah.
Yeah.
And this is the spring sky at midnight.
Oh, it's below the horizon. Got it.
Zenith. Yeah. So this is the realm that I consider, or the realm of galaxies. And I think that those are the coolest things to image.
Mm-hmm.
So down here in Coma Berenices in Virgo,
Mm-hmm.
Virgo's down here. This is the local cluster. Up here in Leo, you have some really nice galaxies. You have M65 and M66, and the one they don't show for the Leo triplet. And then there's another triplet over here of galaxies. And then up here during, this is of course the North Pole, or the pole star. And up here in the region around the Big Dipper, you have many other very nice galaxies. M101, I think is the one behind me, and
No.
M51, M63, a lot of these things. So this is the sky you have available for looking. Where's M51? We did that.
It also shows, Jerry, it shows nicely how the dragon goes looping in between the Little Dipper and the Big Dipper.
Oh, yeah.
Yeah, that's how I have when I show people the sky and they're looking for the dragon, just look for those dippers, you know.
Uh-huh.
And then Thuban there, the previous North
Mhm.
Star.
Mm-hmm.
So what we're looking at is sort of like a part of the filament, those filaments that make a spider web around the universe.
No, that's a much
No.
bigger scale than this. These are just asterisms in our sky that you can see with the naked eye.
But those galaxies are those galaxy clusters are distributed along those filaments.
Right.
Mm-hmm.
And just the yellow one, the yellow numbers.
Well, those are Messier objects. Some of them weren't galaxies,
Oh,
but
okay.
most of them were.
These
Got
are
it.
individual galaxies, the blue stuff, and these yellow are clusters of galaxies. This is also a cluster up here. So, and that brings up a good point. Chuck just mentioned the Messier stuff, and this is the season coming up when you can do the Messier Marathon. Try and see all 110 objects in one night with enough coffee.
Yeah.
Well,
And you could get a rest in between.
Yeah.
I would assume old man Messier was northern hemisphere. He missed a lot of things in the southern that he can't see, probably, right?
He was in Paris.
Yeah.
Yeah.
I
Okay.
think the latest Sky and Telescope has a page on the pecking order of how to go about doing the marathon. So it's kind of
Yeah. And when you go, Tim, when you go for the galaxies in the Virgo cluster, that's when you can take it easy doing the marathon.
Yeah.
boy, I
And
don't know
it's
about
no
that.
fair using a
Those are
go-to
tough.
scope for the marathon.
Well, did the NGC classification come along and just get everything he missed, or sometimes they're both,
No.
they have both numbers,
Yeah, they have both.
both M or NGC?
Yeah.
Okay.
Mm-hmm.
The quality of telescopes improved when they were using bigger telescopes when the NGC was born. And so there's a lot of things that Messier didn't see.
Yeah.
Fainter objects. And some that it's really puzzling that he didn't include.
Yeah. Like the double cluster, Jerry?
Yeah.
Well, okay, so initially he was doing fuzzy stuff,
Yeah.
Yes.
but then he realized that Herschel in England was just basically putting in everything he could see into the catalog. And he thought, well, if I pad my catalog a little, I might get elected to the French Academy of Sciences. So he started to add things like the Pleiades that obviously weren't.
Is there major stuff in the southern hemisphere that we'll never see? Major fuzzballs and galaxies?
Oh,
Do they
yeah.
have their own system down there?
I'm sorry, what?
Is there another system for the southern hemisphere, the Australia people and
No.
New
Another
Zealand?
system? You mean another galaxy catalog or something?
Are there things in the sky we'll never see that'll never come above the horizon?
Yes. Oh, of course.
But they're
Okay.
still in the catalogs.
Yeah.
So old man Messier and the NGC guys got them anyway somehow.
Not
They-
Messier. Not
Not
Messier.
Messier. No,
Not
that's
Messier.
Herschel
That's
took
Herschel.
one of his telescopes and went to South Africa and
Right.
John,
guy there.
John Herschel. Yeah.
John
Yeah,
Herschel.
John, yeah, the sun. Mm-hmm.
And that was the beginning of the NGC.
Mm-hmm.
Yeah.
Well, these galaxies we're looking at, can they be seen in the south?
Some of
Depends
them.
how close to the ecliptic they are.
Yeah.
Okay.
The southward around the North Pole, what is it? There's a phrase of it there.
Circumpolar.
Here.
Mhm.
Circumpolar, thank you. That stuff you don't see from the southern hemisphere.
Right,
Just like there's stuff around the southern pole that we don't see.
right.
You
But
know,
if you're at
that,
the equator, you see everything.
that
Yeah.
never occurred to me. In the southern hemisphere, they can't really do the Messier Marathon, right?
That's correct.
Oh, no,
Huh.
no.
Interesting. I never even thought of that.
Yeah, and Tim, it was fun for me on Friday. I went up to the deck to spend time with Tom Taunton, and there was Canopus.
Oh,
Yeah.
really?
Oh,
He had never seen it before, so it was pretty cool. I showed it to him. It was just hovering above the horizon there. Yeah.
Yeah, you can get a little view from that deck.
Yeah.
It's like your backyard.
Yeah. Yeah.
yeah.
Except we don't have that many trees. You know, there were a lot of trees there when you look south from the deck at Westmont.
Oh, yeah. Yeah, they could use a couple of good chainsaws.
Well, can you gentlemen tell me about the Messier Marathon? Do you get credit or you sign up?
You get self-satisfaction.
Yeah.
You can get credit for it with places like the Astronomical League, and they'll give you a certificate, you know.
Yeah.
How do you prove that you saw it all?
Oh, it's honor system.
Yeah.
Yeah.
And none of you have done it.
Oh,
None of you have done it, right?
Oh, yeah.
yeah.
We've done Messier marathons in the past. We used to go up to West Camino Cielo and spend the whole night up there doing that.
Right.
But is it all stuff we can see with the naked eye, or do you need a
Oh,
telescope?
no. Oh, no. See those galaxies, Ron? That whole bunch of yellow down there?
Yeah.
They're fake.
Oh, none of those you can see with your eyes. Not even
Well, how big-
87. Not even 87.
Yeah, the big dog.
How big was old man Messier's telescope? How many inches?
3 inches.
3 inches. Okay.
3 inches.
Is a refractor.
Okay.
Yeah, but he also didn't have a whole bunch of light pollution.
No.
That's true. Even in Paris.
Right.
Candles don't create a lot of light pollution.
No, that's why they stayed in the cities mostly until modern times, when they started moving out to hilltops.
Yeah.
I was
And you
looking
can
for it
see-
earlier, but
Yeah.
M81, M82 are way out here.
Yeah, Tim
Yeah.
called those in on Friday night for me.
Yeah, they were
Cool.
pretty good.
Yeah,
Yeah.
but you can frequently get the two of these in a single field of view on a smaller scope.
Yeah, Tim did it. He did it with his F5.
Very
And
nice.
and one of the Sea Star people had them both too.
Okay.
Okay. Yeah.
Oh,
And the way
really?
you
Okay.
way I find them is to take these two stars and just extend that up.
Mhm.
Yep. One more. There's also an arc of stars that Joe told me about, but you need a pretty dark sky to see that arc of stars. So
Mm.
the best hop is the one you mentioned, Jerry.
Uh-huh.
Yeah.
Okay. Moving
Well,
on.
I used to do, astrophotography from my deck when we had the sodium vapor streetlights. But ever since they've gone to the LED streetlights, it just wipes out the sky. I have to leave. Go up with me in a halo or something like that.
Yeah, there's a definite need for a BB gun.
Yeah,
A
22.
BB gun won't do it. You need a 22.
Oh,
How about a paintball gun?
oh, there you go. That's best.
Yeah, black paint. Boom, boom, boom.
Yeah.
There's a neighbor of mine that for some reason the streetlights in his vicinity don't seem to stay working. And when the guy was out there, he picked up the sender and he shook it and it rattled. That's because the 22 slug didn't go didn't go out the other side. Yeah, he says the way you take care of those is you need a car that has a sunroof and you drive directly underneath the light and you go bang and you drive away.
God.
And then there's the way we put out the lights in Camino Cielo Marketplace.
Oh, wrap them?
Cardboard boxes, yeah.
Yeah, that would be nice if there was some kind of a skirt that you could put up on some of these in neighborhoods. But we've now got one of these LEDs as well, and boy, they are bright.
I spent like 6 months. We used to have a big jacaranda tree that covered up our light, and it was a cobra head vapor light. And so it wasn't too bothersome because the tree covered it up.
Yeah.
But then the trees were heaving up the sidewalk, so the county came and cut down the trees. And suddenly my house, the front yard and the house was like being at a car dealership.
Yeah.
So,
like in Camino Real Marketplace.
and so I sent a bunch of letters and emails. First the Edison said it was the county's responsibility. The county said it was Edison's, and
Oh,
finally
yeah.
I sent a letter after 6 months. I sent a letter to the vice president in charge of consumer relations at Edison and complained about the light and light trespass. And sure enough, 2 weeks later, this truck pulls up and a guy pulls off the sodium vapor light and lets all the acorns fall out of it from the local woodpeckers. And then he put in this LED that was low temperature, and it was nice. It wasn't fully shielded, but it was nice. And then 7 months after that, another Edison truck pulled up and put in a gigantico LED light.
Yeah.
Back to car dealership levels.
Wow.
Well, they used to have it so if you could get slightly above the street light and shine a laser into the sensor on top of it, it would turn it off. But then on my street over here, Cathedral Oaks Road, it's a neural network, and so every street light gets to vote. So you have to tell them all it's bright light. So
I know with our lights, if you could manage to hit the sensor, it would go out, but then about half an hour later, it would pop back on.
yeah.
You need a stronger laser that actually burns out the sensor.
Well, I'm trying to do it without leaving evidence.
Yeah.
So,
That's why when you put a 22 through the sender, you don't want to do it from your deck. The car directly underneath it doesn't leave. They can't do any forensics to decide where it came from.
You got a devious mind, Bruce.
So the new LED era is worse.
Well, just remember the Latin, illegitimai non carborundum.
Yeah.
Don't let the bastards grind you down.
all right, can you guys see the share?
No. Oh,
Okay.
well, wait a minute. I'm in a different mode, I think. Yes, it's there.
Yeah, there we go.
Okay.
Okay.
So I put in a little section about the scientific process. And in researching it, I find that there's a very wide range of differences on how it proceeds.
Yep.
But my view of it is that the scientific process is a three-stage process. It is a process, and that's key to it. It's not a collection of answers or data or things. It is a process to solve problems. It generates scientific knowledge, which is how we describe, planets and stuff. But it's a process of solving problems. And in the age of, we'll get to that. The process is that you start with a hypothesis or an observation or a question or a postulate or a hunch or an inspiration, or you look on your neighbor's paper and you get an idea. But somehow you get an idea. And examples of famous starting hypotheses are the Earth is the center of the solar system. The sun is the center of the solar system. The Earth is flat. The Earth is round. There is an absolute time in the universe, and there is no absolute time in the universe. For example, the speed of light, this is a postulate of relativity. The speed of light is always given by c, 3 times 10 to the 10 meters per second. No, or kilometers per second. 10 to the meters.
3 times 10 to the 8th meter per second. Yeah.
Yeah. No matter how fast the observer moves. That is, if you're doing 90% of the speed of light and you hold the flashlight out and you turn it on, the light goes out at the speed of light from you holding the flashlight and to someone that you're passing on the sidewalk. Speeds are not additive, which you can tell by your personal experience driving cars that they are additive. But that's only at low speeds. So then you describe your hypothesis mathematically, and then and the reason you do that, any form that opens up to deductive logic. So that once you take your hypothesis and you mathematically, by deduction, you derive observable consequences of your postulate. For example, if the Earth is flat, you would derive the fact that the shape of the Earth shadowed on the moon would be a straight line.
Oh,
Not-
yeah, I forgot about that, yeah.
So you figure out observable consequences, and then you look and see, is that what we're seeing?
David
finally-
Larson actually has a good counter to the hypothesis that the Earth is flat.
Yeah.
Stage number one is there are cats on the Earth.
Oh, yes.
And number two is they would have pushed everything off the edge.
Yeah. Finally, you set up experiments or make observations to see if the derived consequences actually occur. That's how you test it. And when you make it up, you can, if you like the idea, you can just don't test it and it becomes a belief system. You believe it, you like it. But belief is a psychological thing that makes you feel good. It's not necessarily true. So, and a corollary, of course, is it's a good idea to publish your work and get critical feedback, because once it gets out, you'll get a lot of critical reviews of it. So,
Just
so whoops,
did
things
this-
are out of order.
Did the string theory guys come through quantum? Whoever came up with that little strings, little vibrating, I know you're not.
That's trying to reconcile both quantum and Einstein.
Strings vibrating.
Yeah.
Okay,
Yeah.
got it.
Pretty well given up on that, have they not?
It's hard to get a testable hypothesis from what they're coming up with.
Old Machu Kiko likes that stuff. Okay, Albert, here he is.
We're going to get to that next. That's out of order. An example of the science is only a couple of hundred years old, half a millennium or something. It really started officially, formally in the Renaissance, the Age of Enlightenment, and it pretty much brought the Dark Ages, where the world was primarily focused on religion. It brought that to a close, and it has had tremendous results. One of the best geniuses of all time, I guess, is Isaac Newton. Although not a very good human being, he was a brilliant man. He invented, he made observations and developed the law of gravity, Newton's law of gravity, and his three laws of motion and calculus. He was not the only one to vet calculus, but he was there at the same time. This is his Principia Mathematica cover, which was in 1686. It was published, and that thing got things going pretty well. The first is three laws of motion, is that the first law is everything has inertia. So if you have an object that's moving, and unless something acts on it to change its motion, it will keep moving in a straight line. The second law is the change of motion of an object that's moving or not moving, starts to move, is acted on by a force, and that will move it out of a straight line. The third law is for every action, there is an equal and opposite reaction. These laws are all based on hidden assumptions that there is an absolute time, and that inertial mass and gravitational mass may not be equal, and that velocities add. And these come from our senses. We feel these things because of our personal experiences. These were all three of those precepts were overturned by relativity, but we'll get to that.
And it was Edmund Halley who actually had to sort of done Newton to publish Principia.
Yeah.
They were arguing with Hooke about whether gravity was 1 over r squared. And they happened to mention it to Newton. He said, "Oh yeah, it's 1 over r squared." And they're like, "Well, how do you know?" And he says, "Oh, I worked all that out during the plague while I was out on the farm." And they really had to push him to publish, and Halley ended up paying for some of it.
But the way they got him to publish, I heard, was that they told that someone in Germany was about to publish the same thing.
Aha.
Ah,
So anyway, this is his first law, inertia. Here's your SUV going along with a box sitting on the top, and the SUV makes a sudden stop, but the inertia of this one keeps it going. So it will only stop by, there's a lot of problems with this being a good example is that there's air drag and friction and stuff, but you have to think of it in an ideal sense. The second law of motion, or his law of gravity, their curved orbits, it doesn't move in a straight line. When acted on by a force, it moves in a curved line. That describes orbits, and we use that today to send things to Mars and land them accurately on the surface. We don't need anything quantum or general relativity developed since to do that. We do all of our spacecraft stuff, pretty much all of it, with Newton's laws. And the third law, of course, for action and reaction, that's the principle that makes our rockets work. So then, let's get back to this. Oh, did I cover that up?
Nope.
Okay.
It's good.
So in 1917, Albert Einstein examined higher velocities, heavier masses, and the postulate that time is relative to the observer. And so this is a realm that Newton did not have instruments to explore, and he did not have the mathematical network to explore it mathematically. But Einstein branched out to a region that Newton did not work in. So it does not prove that Newton's work is wrong. Newton's work is simply a special case of a more general theory. It was not wrong. The idea that science is continually changing because of finding out past stuff was wrong, that's a misconception, and it's an anti-scientific argument. There's one that religious people like to make now that says that science is falsifiable. That is, if you find one piece of evidence that counters it, then science is wrong. But you can't falsify religion because it's not evidence-based. So it's a fallacy argument, but it is gaining ground in religious circles. So anyway, Einstein's theory of relativity consists of two main theories, special relativity and general relativity. Special relativity is for uniform motion, and general relativity adds in acceleration. Special relativity states that the laws of physics are the same for all observers, regardless of their relative velocity. So this is velocity-based. General relativity extends this by including effects of gravity, which is described as the curvature of space-time caused by massive objects, more massive objects. General relativity successfully explains the orbit of planets and other astronomical observations in details that are not necessary to get a spacecraft to them. So we still use Newtonian dynamics for that. Both special and general relativity have been confirmed by numerous experiments and have become integral parts of modern physics. And it has, go ahead.
Actually, what you just said explains why my computer program results agree with NASA's, because they didn't use relativity either.
No, there's no need for it. The only thing that we do on a common basis that we need general relativity for is GPS position, the data reduction. You would not have accurate GPS results if you didn't account for the difference in time between a moving object far away from a mass compared to a static object close to the mass. So, where am I getting with this? Oh. Huh. Okay. So this, you can see these 6 little frames here, theory of relativity.
Yes.
Okay. So this explains the key differences between the theory of relativity as we advance. Time is the 4th dimension, and it's not fixed in space. Clocks do not move at the same rate anywhere in space. It's like you had a big farm somewhere, and you move your sheep down to the lower quarter there because time goes really slowly there, and you don't want your lambs to age. So you move them down there and they age very slowly. If you need one, you go down and get it and bring it back. light speed remains constant no matter who's looking at it, except if you're looking at it at the speed of light. And you can't go at the speed of light because E equals mc squared says that the mass increases as you get close to the speed of light. And to travel at the speed of light, you would have to have infinite mass. I mean, you would have to have the infinite energy to get to the speed of light.
And also there, that needs a tiny caveat that light speed remains constant in a vacuum, but it can change as it goes through another medium.
That's an emergent property. What happens is in that, and it confuses a lot of people in physics when they start, because the light goes into a glass and then it hits the first layer of atoms and it interacts with the atoms. That takes a certain amount of time. And then they re-emit it down and it goes to the next level of atoms, and then they sample it and then they send it on. So that little time that it takes to go through each lane to interact with the atoms, that's what makes it on the outside appear to net move slower. But between the atoms, it's moving at the vacuum speed of light.
Now, something confuses me here that you had said earlier, and in the program here, is that if you're moving in the same direction as a beam of light, and you're moving at a increased speed, wouldn't that light slow down?
No.
And the answer is no. And I just don't understand that, why it wouldn't.
Because it always has to go that speed.
Yeah. It's independent of the observer.
Huh.
Okay,
So,
moving on.
If I'm in a spaceship that's going very near the speed of light and I have a powerful searchlight and I shine out ahead of me, do I catch up with that light?
No.
No.
From your point of view, it moves away from you at the speed of light.
Yeah. And someone
that concept is hard to grasp.
that's because you're thinking classically, and it is hard to grasp. All of these things in relativity are counterintuitive. That's why they published a book right after Einstein published his theory. That 100 scientists claim that relativity is wrong. And Einstein's famous retort was, why 100? If I was wrong, it only would take one. Science is not a popularity contest. But the faster you move through space, the slower you move through time. That's why the speed of light still looks the same.
Ah, that makes sense.
Gravity is the curvature of space-time, not space, but space-time. It folds space into time.
That's why it travels faster than the speed of light.
Say that again.
That's why gravity travels faster than the speed of light.
No, it doesn't. It travels at the speed of light.
At the speed of light.
Well, but the point is that, you can have things that are in orbit about other things and they get the gravitational pull immediately.
No.
No?
No.
All right. I was wrong again?
No, Bruce, I personally have gone through all the epiphanies that you're now struggling with. Your thinking is classical thinking. It's a good thinking, but it's a different mindset to try and understand relativity.
And then if you want to get even weirder, you go to quantum.
Yeah.
I think I've got a toehold on relativity, though.
But the thing is, if you speed up toward the speed of light, you're slowing down time-wise, aren't you?
Yeah.
Seems normal to you, but
yes. And as a matter of fact, if you were a light particle moving at the speed of light,
there'd be no time.
There is no time.
There'd be no time.
Yeah, the speed of light doesn't matter to the light.
That's why it seems to me you could almost say that time goes through us at the speed of light, but I guess that doesn't hold water, does it?
I don't know. I'd have to think about that. Strange things have been said.
Here's what doesn't bother me, but it makes me wonder. It's like we get a free ride forever, whatever it takes to get you blasted into space. Let's take the Voyagers, for example. They got a free ride, no more power needed, as long as they don't hit anything, right?
That's correct.
They could go clear across the universe forever for free. If we do that down here on Earth in a car, we run out of gas.
Yeah, because we're always fighting friction.
Okay, so that makes me wonder, is there friction in space? Aren't there little molecules and atoms here
Yes,
in
you can
the
run into things in space. As a matter of fact, I've always thought that when I see a Star Trek show and they're running in hyperspace, they're running into dust particles at a rate that would actually erode their ship away to nothing,
Yeah.
like a super sandstorm.
except they all have these magnetic fields around the
It would
aircraft,
have to be some, it would not be magnetic field, it would have to be something.
something big and
Yeah.
Yeah,
Well,
the
anyway,
magnetic field would only get charged particles.
Yeah. And that would form what's called a Dyson engine, where you have a big magnetic field scoop out front, you suck in the hydrogen atoms, and then you fuse it, and that gives you power to blast forward.
That's a Broussard ramjet, it's called.
Broussard, that's right, you're right, you're right. Time slows down around heavy objects. That was illustrated in the movie Interstellar. And then gravity travels in the forms of waves at the speed of light. And because it travels through space-time as waves, you can tell that space-time is itself a elastic medium. And it has an elasticity constant about 10,000 times stiffer than steel. But it is a material and it is elastic.
Hmm.
wow.
And we
We
swim
got to
in
talk.
it, and we don't notice it. So the analogy with, does a fish really understand water? You know, so that's all we have time for today, but there's more interesting stuff
Oh yeah.
Yeah.
about
Please
science.
do more of that, Jerry. That was good. Even when I'm tired here, that woke me up.
Okay, oh, sorry about that.
No, it woke me up. I was
Okay.
that was really good. I
The
always enjoy this.
The only cartoon you didn't throw up at the beginning was the one I got during the week. The oh yeah, misinformation table. Remember? You said that to us, and it didn't show up. But anyway, maybe
Oh,
next
I
week.
must have missed that one when I went back.
Okay. Well, look, guys, in 2 weekends, we will be having another First Friday and a second Saturday, right, day after each other. Dr. Jeff Bennett will be talking to us beyond UFOs on First
Yeah.
Friday, which would be the 7th, I
Yeah.
guess, of March. In the
Yeah.
meantime, welcome to our 5th year, starting next week, the 3rd of March. Gentlemen, take care of yourselves and give my love to your family and wives and your grandkids, and we'll see you on the SBAU Astro.